Good morning, dear students. So already we have studied the cooling system, different types of cooling system and components of these. So now we are going to the another important system in IC engine, that is the lubrication system. So in this session we will discuss different types of. So before going to the different system, types of lubrication, the need system, of lubrication, we must understand etc. What is the purpose of lubrication system? So why we require a lubrication system in an IC engine? So lubrication system have different functions. We will discuss some of the main functions of lubrication system. We know that in IC engine all the parts will have some sort of relative motion and will rub against each other. For example, we know that our piston is moving, reciprocating inside the cylinder, crankshaft is rotating, connecting rod is also moving, valves are moving. So a number of moving parts, high speed moving parts are there. And we know whenever there is a relative motion, the friction will come into play. So lubrication reduces the friction by creating a thin film between the moving parts. So this is the main purpose of lubrication. So like this, this is a shaft which is rotating inside a bearing, and if there is no lubrication means it will contact this surface, two surface will have some contact and friction will be there, and ultimately some wear and tear will happen. So to avoid that, we are applying a thin film of lubrication oil like this. So this is the major function of a lubrication system, to reduce friction so that we can avoid the wear and tear of each components. And another function of lubrication system is it helps to form a gas tight seal between the piston rings and cylinder walls, and it reduces blow by. So what is blow by? Blow by is, we know that this piston, we have 3 piston rings and it is moving inside a cylinder. So there will be a small gap in between the piston rings and the cylinder. Then only it can move freely inside the cylinder. So there is a chance that this gas above the piston will leak into the crankcase. That is known as the blow by. It is a loss in a 4-stroke engine, but in 2-stroke engine already the working will takes place in the crankcase, but mainly in 4-stroke engine there is no working in the crankcase. So there is a chance of leakage of the gas from here to this crankcase. So that is known as blow by. So when we are applying a lubrication system, there will be an oil tight casing, oil tight seal will be formed between these piston rings and the cylinder. So the gas will not enter into the crankcase. So that is the another function of lubrication system. This is mainly in 4-stroke engine. It helps to reduce the blow by forming a gas tight seal between the piston rings and cylinder walls. And lubrication also helps in cleaning carbon particles, metal particles, etc. Because our lubrication oil is circulated through every component. It will clean the surface of this component, and these particles will be bring down to the sump or pan, which can be filtered back. So like that, it helps to clean the surface of different components. And another function of lubrication oil is, during heavy loads, it acts as a cushion and absorb the shock. So it acts as a shock absorbent in a smaller extent. That is also done by the lubrication system. And finally, the circulation lubrication will also help to remove some heat. So it helps in cooling. Already we have a separate cooling system. This circulation lubrication also helps to remove some heat because it is circulated through most of the components. So this is the function or need of a lubrication system. In this, the first one is the most important. All other remaining function is only subsidiary. Now we will discuss the different types of lubrication system. Before that, we must have some idea about viscosity. The viscosity is the important property we are focusing while selecting a lubrication oil. We know that we cannot use a lubrication oil for a two-wheeler into a four-wheeler or a smaller vehicle into a heavier vehicle. They are very specific. Why they are very specific? Because each lubrication oil will have different viscosity. So viscosity is the most important property associated with lubrication oils. So what is viscosity? Viscosity is a measure of resistance to the flow. Or we can say it is a resistance offered by one layer of fluid over the adjacent layer. And another thing is viscosity will change according to temperature. This is an important point. Even though we have a particular viscosity at room temperature, when temperature increases, it normally the liquid viscosity will decrease. Similarly, when temperature decreases, viscosity of liquid will increase. So there is a relation between temperature and viscosity. So that this is an important point, because our engine will be operated in a particular range of temperature. It is not operating at a constant temperature. Sometimes the temperature will be 500 degrees, sometimes it will reach 1000, above 1000 degree. So we must be very careful while selecting our lubrication oil. And another thing is, if our oil is too thin, that means it is having very less viscosity, it will be forced out from between the moving parts very easily, and it will result in rapid wear. So we cannot select a particular lubrication oil with low viscosity. Why? Because of this reason. If you are selected a lubrication oil of low viscosity, it will easily move away from the parts, resulting in wear. And what happens if you are using an oil with very high viscosity? This also has some problem. If you are using an oil that is too thick or with very high viscosity, it will flow only very slowly. We know that the resistance will be more, so it will flow only very slowly. So it takes more time to reach the engine parts. So it also will help in wear. So that is the important thing. If the viscosity is very less, it will increase the wear, and if the viscosity is too high also, it will result in wear. So we have to select an optimum viscosity for our oil in a particular engine. So for that, we have a viscosity index. It's a measure of how much the viscosity of an oil change with temperature. So every lubrication oil is associated with some viscosity index that represents how the oil will change with temperature. And we have given a viscosity number to every oil by Society of Automotive Engineer, SAE, US. So every oil, lubrication oil, is having a SAE number. So that number, like this, will have most of them will have two number associated with it. For example, 0W16, 0W20. So this W represents the winter. So in cold condition, its viscosity number is 0, and in hot condition it will reach to 16, and each of this number is having a particular viscosity. So you can see here most of the number is associated with two grades. One is the winter viscosity number, other one is the hot condition viscosity number. But some oils, monograde oils, some are having only one number, so they can't use for different temperature range like this. So this number is fixed by SAE. So if you know the number of your lubrication oil for your engine, which will be specified in your manual, or we can easily purchase that oil and use it. So this is an important property associated with lubrication oil. Now what are the types of lubrication system? Mainly we have three classifications. First we have mist lubrication, Then we have wet sump lubrication. And in wet sump lubrication, again we have three types of lubrication possible. That is splash lubrication, pressure feed lubrication, and combined splash and pressure feed lubrication. And another we have dry sump lubrication. So mainly we have these three types of lubrication system: mist lubrication, wet sump lubrication, and the dry sump lubrication. Now, what is mist lubrication? So mist lubrication is mainly used in two-stroke engine. So what is the peculiarity of two-stroke engine? In two-stroke engine, we know that the crankcase, the covering of the crank, in that also the air fuel mixture will be entering. So air fuel mixture or air will be entering initially through the inlet port in the crankcase. So we cannot use the crankcase as a collection, storage or sump for lubrication oil. But in four-stroke engine, we can use this crankcase as a sump or collection of lubrication oil. But two-stroke engine, we are not able to use that because already there is air fuel mixture happening, entering in this crankcase. So what it will do, we will simply mix a 3 to 6% of lubrication oil with the fuel. So when filling petrol or diesel in that engine, we will mix 3 to small percentage of lubrication oil, and it will be injected to the carburetor or whatever the system is. And when due to the high temperature inside the cylinder, the fuel will be vaporizing, and at the same time the lubrication oil will form as a mist. That is why it is known as a mist lubrication. So this lubrication oil, due to the high temperature inside the engine cylinder, will form as a mist, and it will go to the cylinder and other components. So that is mist lubrication. The main advantage is it is very simple and it's very less cost because no components. We does not require any additional components for mist lubrication. We are just mixing the lubrication oil with the fuel. But it has several disadvantages. One is, with some lubrication oil will be burning since it is inside the cylinder. Some of the lubrication oil will results in burning, or the combustion of lubrication oil will happen, and it will results in heavy smoke. So this is also one of the reason why two-stroke engine emissions are more. So in two-stroke engines there is a chance of burning of lubrication oil, which is very undesirable, and it will produce a heavy smoke. So that is one disadvantage. And another main disadvantage is, suppose we are moving a vehicle down the hill, we will not press the accelerator pedal, or it will be known as a closed throttle operation. So fuel will not be entering into the cylinder in that case because our throttle is fully closed, very less fuel will be entering. So the lubrication oil also will be very less since it is mixed with the fuel. So in that case, the engine will suffer from insufficient lubrication. So this is an important limitation of this type of lubrication. So when a vehicle is moving down the hill, or it is moving without pressing the accelerator pedal, the fuel quantity will be very less entering the engine. So lubrication oil will be less. So it will result in insufficient lubrication. So these are some limitations of mist lubrication. So that is why it is only used in some two-stroke engine. Now second one, we have wet sump lubrication. So what is wet sump lubrication? So in wet sump lubrication, mainly the bottom of crankcase contains the lubrication oil, or it is a sump, act as a sump for collecting the lubrication oil, and from which the lubrication oil will be pumped into different components. So our crankcase will act as a sump for lubrication oil, and it will be always wet. That is why it is known as a wet sump lubrication. Our crankcase will be always in wet condition, always it will be full of lubrication oil. From there it will be pumped into different components. So this is a representative figure of that. So this is our crankcase. So in this figure, no other components are shown, only the lubrication system is shown. Piston, connecting rod, etc. are avoided. So this is our crank case, which is known as the sump, wet sump. So oil will be collected here. So after filtering the oil, because particles will be there, we have an oil strainer. Strainer is a filter. It is pumped with the help of an oil pump. It is pumped to the different components. And we will have another filter also. And we will have some pressure regulating device, etc. So mainly our crankcase collects the lubrication oil. So it is known as the wet sump. And again this wet sump lubrication is classified into three categories, that is splash lubrication, pressure feed lubrication, and combination of this. So we will see one by one what is splash lubrication and what is pressure feed lubrication. So what is splash lubrication? Splash lubrication, this is a figure of splash lubrication. You can see here. The important thing is here at the just below the connecting rod big end. This is our connecting rod, this red one. This is our piston. So this end of the connecting rod is big end. This end is small end. So just below the connecting rod we have oil troughs. We can see small oil troughs situated just below the big end of the connecting rod. You have 4 oil troughs. So how many number of cylinders, that much oil troughs will be there. And a dipper is provided. You can see at the end of connecting rod we have a stick which dips in this oil trough. So this is known as a dipper. This dipper dips in this oil trough. And what happens if the connecting rod moves? This dipper will splash the oil to the every revolution of crankshaft. So that is the splash lubrication. So in splash lubrication, first the oil pumps, with the help of an oil pump we are pumping this oil from this crankcase to the oil trough. These are the oil troughs. And we have a dipper provided at the end of connecting rod, and the movement of the connecting rod will splash the oil all over the interior of the cylinder. So it will splash the oil all over, and after reaching different components it will collected again, this will dip into the crankcase again. So this will be repeated. So this is known as splash lubrication. We are splashing the lubrication oil, and this is used only in light duty engine. We will not be using this in heavier engines. Smaller engines we are using splash lubrication. And another one is pressure feed lubrication. So this is the figure of pressure feed lubrication. Here see, here there is no oil trough or dipper, etc. is there. What we will do is we will directly pump the oil to the distributing channel. We will cut a channel through every component, possible components. We will directly pump the oil to the through this channel through piston, connecting rod, crank, etc. So in pressure feed lubrication, the oil is drawn from the sump and forced to the all main bearings to the distributing channels. So we have a channel to cut through, and we are pumping the lubrication oil through that channel. And a hole is drilled at the piston. So the oil will reach the piston through the hole drilled in the connecting rod. So every component, connecting rod, crank, etc. will have some hole or some distribution channels. So our oil will reach through that hole or distribution channel. And in the cylinder walls, piston and piston rings are lubricated by oil spray from the connecting rod. So after that the oil will be sprayed through the connecting rod bearings. This is our connecting rod. You can see here, sprayed through the connecting rod. At the end of connecting rod, this is the connecting rod bearing position. So while reaches here, it will be sprayed to the other components. So like that, This is a pressure feed lubrication. Why it is known as pressure feed is lubrication oil is pressurized with the help of a pump and moved to the distribution channel, and after that is sprayed. So that is why it is known as pressure feed lubrication. And we can use a combination of these two also. We can use the splash and pressure feed together. That means it will have oil troughs, this dipper will be there, and this distribution channel will be also present. So that is known as the combination of splash and pressure feed lubrication. And finally we have dry sump lubrication. Why it is a dry sump lubrication? Because our sump will be always dry. Our sump is cranked, guys. It will be always dry. How it will be always dry? Because here we have a separate tank for the final collection of lubrication oil. So in dry sump lubrication, the supply of oil is carried out from an external tank. So in wet sump lubrication or mist lubrication, we does not have a separate tank for lubrication oil. But in dry sump lubrication, we have a separate external tank. So that is outside the engine. We have a supply tank here. So from there, we will pump. We have a pump here. We will pump this oil to the different components, bearing, etc. So oil pump circulates oil from this tank to various bearings and other components. And after it reaches different components, it will drip from the cylinder, etc. into the sump. So after reaching different components, it will, by gravity, it will fall down to this crankcase. But immediately it will reach the crankcase, it will be removed by another scavenging pump. So we have a second pump here, that is known as scavenging pump. So after once the oil reaches a small level, this pump will again remove this, and it will bring back to this supply tank. So that means oil is prevented from accumulating in the crankcase. So that is why it is known as a dry sump lubrication. So the thing is, in dry sump lubrication, we have a separate supply tank external to the engine. From here we are pumping our oil with the help of an oil pump, and after reaching different components, it will drip down to the crankcase by gravity. But again we are using another pump. So in this case we have two pumps. But in wet sump lubrication only we have one pump, but we have one oil pump and one scavenging pump. The function of scavenging pump is remove this oil from the crankcase and pump it back to the tank. So mostly for larger engines we are using this dry sump lubrication. So these are the types of lubrication. You does not have to worry about figure, just you have to simply study the classification and function, etc. You can draw a rough figure of this dry sump and wet sump. So with this we are stopping.